All right, in this lesson today, we are going to solve inequalities. Now, solving inequalities is going to be very, very much like solving equations. They're just two or three little things we're going to do differently, so I think you're going to catch on to this pretty quickly. So when we solved equations, when we talk about the word equations, we're talking about the equal sign. So really, one of the differences is that we're not going to have an equal sign anymore. No to equal signs. Solving inequalities will be using the less than, the more than, the less than or equal to, or the more than or equal to. So I'm going to show you some inequalities that look very similar to equations. I've just changed the sign, and we're still going to do the same steps on them as we have done with the equations in past lessons. So let's start off with a nice easy one. The first one is x minus 4 is greater than 7. Now, you know what we did with this when we were doing equations. Remember how we need to move the number away from the x? We need to isolate the x. And how do we move the negative 4 to the other side? By adding the opposite. So I'm going to add 4, so this will clear out, and another positive 4 over there. When I get finished, x is by itself. I have my x. I have my greater than sign as you read left to right, and 7 and 4 make 11. So that wasn't too bad, was it? Okay. Let me get my eraser here. Okay, let's try another one. Let's go for this one. Let's say we have x minus 12 is less than or equal to a negative 18. Okay? Now, we're getting ready to move the 12 so we can isolate the x. 12 is a negative right now, so I need to add a positive 12. That will clear out, and I'll add a positive 12 over here. I'll put a positive sign if you want me to. Now, x is by itself, so we have x. The inequality is less than or equal to. Now, because the signs are different, you need to take the difference. And since we have more negative than positive, the answer needs to be negative, doesn't it? Okay. So the difference between an 18 and a 12 is 6, and that needs to be a negative 6. So there's our answer. X is less than or equal to a negative 6. See, we haven't done anything strange. We just put a little different sign in there. Okay, let's try another. X plus 4, and this time I'll say is greater than or equal to 6. Same thing. Let's tell the 4 to move on to the other side so we can solve for x. Opposite will be a negative 4. Remember, another word for opposite here is additive inverse. So that clears, and we have a negative 4 right here. So x is greater than or equal to, there is more positive than negative, so take the difference, and the answer is x is greater than or equal to 2. Okay? Okay, now I'm going to throw a little something weird here on you. Here we go. I'm going to go a negative x. I can put a negative 1x or a negative x. A negative x is greater than 6. Now, I told you there are very few rules that are different from the equations. Well, this is one of them. You know that if we were doing an equation, that we do not solve for a negative variable. So I purposely put the 1 up here to remind you that that negative x is a negative 1x. So you know that we're going to have to divide both sides by a negative 1 to force that x to be positive. So I will now divide by a negative 1 and a negative 1. When I do that, two negatives clear out to make a positive 1x. A negative 1 into 6 is a negative 6. But here's rule number 1. When you're dealing with inequalities, if you have a negative variable and you have to divide by a negative to make that variable positive, this sign, by the time you get to the end, has got to change directions. So rule number 1 right there. If you get to the end and you have a negative variable and you have to divide by the number of negative you have on that variable, you're going to have to change the sign. So remember to do that, regardless of whether it's a -1 or a -6, it doesn't matter. Okay, that's rule number 1 you need to keep in mind. Okay, let's try another. Okay, I'm going to go 16 plus x is less than 5. Okay, who should be moving here? I have to isolate the x, so let's tell 16 to move. We do that by adding the opposite. -16 to clear, and a -16 on this side. We now have x isolated, so we have x less than, and we have a 5 and a -16. Now we need to take the difference between the two of them, and the difference is 11, but it's going to be a -11, isn't it? Okay. -11, all right? Let me tell you one more thing that goes a little weird sometimes for students. I tell them the rule, we discuss it and we work some of the problems, but then they think because I'm moving the 16 with a -16 that I should change the sign. It's not about moving numbers, it's about do you have a negative x at the end? And if you do, then you must change the sign. So don't get the urge to change the sign just because I'm taking away 16 and moving it to the other side. The x was positive, there was no need for a sign change on that, okay? All right, let's try this one. This looks like a good one. X minus a -4 is less than 8. Now, some of you are going to forget about this. This is tricky. I am subtracting a -4. Now, either way you look at it, I see a negative outside of parentheses, outside of -4. And that negative is kind of like a -1. And when you multiply a negative times a negative, you get a positive. So you can do one of two things. You can pretend like it's a -1 and multiply and get a +4, or you can say, well, wait a minute, this is subtract, and I don't subtract. I keep the first one. Remember, subtract means add the opposite, so I'm going to add, and the opposite of that -4 is a +4. So now I have x plus a +4 is less than 8. Now we can move the +4, by adding a -4 on both sides. That clears. X was always positive, so there's no need for a sign change. X is less than. You have more positive than negative, so we're going to vote for a +4 on that one. All right? Okay, let's try a fraction. It's not going to be a bad one. I'm going to go 1/6 x. No, excuse me. 1/6 plus x is greater than, no, let's try that again. 1/6 plus x is greater than 3/6. Now, just because it's a fraction does not mean we have a problem. I do want to move the 1/6 to the other side. The good news is that they still have the same denominator, so let's just move it like we would move a decimal or a whole number. I'm going to take away 1/6 to clear, and over here I'm going to take away 1/6. So now x has been isolated, so I have x is greater than, and 3/6 minus 1/6 is 2/6, and 2/6 can be reduced to 1/3. So that wasn't bad, was it? No. Okay, let's try another, maybe where we have to get a common denominator. Okay, I'm going to go 1/5 minus x, is greater than or equal to 3/10. Now, I've thrown a couple of interesting things in here on you, so watch out. Okay, first of all, I agree that we do want to move the 1/5 to the other side. So let's go ahead and do that by adding the opposite. I'm going to do a minus 1/5 to clear. And over here, I'm going to do a minus 1/5. I now have a negative 1x is greater than or equal to. But you know what? I've got to get a common denominator here. And the common denominator for 5 and 10 is 10. Okay? So that means I can keep the 3/10, but I've got to turn 1/5 into tenths. 5 into 10 is 2, and 2 times 1 is 2. So now we have 3 tenths minus 2 tenths, which is 1/10. Okay, but we have a little bit of a problem. I'm going to go ahead and put that 1/10 out here. Okay, 1/10. But here's the problem. Look what we have here. We have a negative x. Not good. So I think what we need to do is we need to divide both sides by a -1. And when we do that, we're going to have x. Remember, we got to change the sign. And our positive 1/10 now changes to a -1/10. So we had 2 things to do on this one. We had to get a common denominator after we made the move, and then we had to divide by a negative number to get the x to be positive, which forced a sign change. All right? Okay, in our next lesson, we'll go just a little bit deeper.